Hello, this is going to be a recorded lecture video on Chapter 4 out of the Pharmaceutical Calculations textbook. This subject is going to tackle ratios, proportions, and percentages. So our chapter objectives say that by the end of this chapter, you should be able to solve for X using proportions, convert percentages into ratios and fractions, convert ratios and fractions into percentages, convert percentages to decimals, and convert decimals to percentages. You'll also learn to convert percentages to fractions, convert fractions to percentages, and convert fractions to ratios. You'll also learn to determine percentages of various whole numbers. So we're going to start with Unit 1, which is going to focus on ratios. So a ratio is the relation between two numbers. Ratios can be written as fractions or as numbers that are separated by a colon. So they give us the example here, just showing that it can be expressed as a fraction as 1/2, or separated by a colon, which is verbally said as 1/2. So to change a ratio into a fraction, the first number in the ratio becomes the numerator, and the second number in the ratio becomes the denominator. When expressed as a fraction, a ratio can then be reduced to its lowest terms. So they give us some examples here. Start you with the fraction of 40/60. That can be expressed as a ratio written as 40:60. That colon means 2, T-O. Again, that could be turned back into a fraction that is reduced to its lowest terms, which is 2/3, right? Because 40 can be reduced down to 2, 60 can be reduced down to 3, and then that can be re-expressed as a ratio 2:3, or 2:3. And they continue that same example with 6/8. So as a ratio, it would be expressed as 6/8. That can be reduced down to 3/4, expressed there as a fraction. And again, converted right back into a ratio with the 3/4. And then the last example we have here is 8/100. So we could set that as a ratio, 8/100. That reduces down to 2/25. And that 2/25 can then be expressed as a ratio 2/25. Couple more examples. We have 20/4000 expressed as a ratio is 20/4000. That is reduced down to 1/200 back as a fraction, and then back into a ratio as 1:200, or 1/200. And then the last example is 60/1200. Again, that can be expressed as a ratio 60/1200 that is reduced down to 1/20 as a fraction, and again converted back to a ratio as 1:20, or 1/20. So here we have a knowledge check. How will you express the fraction 2/100 as a ratio? Well, remember that first number you encounter is going to become the numerator, or the top number, and the second number you encounter is going to become the denominator, or the second number. So this is provided to us as a fraction. To express it as a ratio would be 20:100, and that can be reduced to 1/5. Because 20 goes into 100 5 times. 20 divided by 20 is 1. So 1/5 as a fraction, and then that fraction could be converted back into a ratio as 1:5. So there is the answer as a ratio, lowered down to its lowest terms. Just in case you didn't follow what I said verbally, let me just show you here on the board real quick. We had 20/100, right? So when we first convert that into a ratio, it becomes 20 to 100, right? Again, both of these numbers are divisible by 20. So if I divide 20 by 20, I get 1. And if we divide 100 by 20, we get 5. So that can be expressed as the fraction 1 over 5. And again, converted back into a ratio as 1 to 5. Okay. All right. So let's move on into Unit 2, which will focus on our proportions. Sorry, I'm trying to get this box at the top to go out of our way. Sometimes it will, sometimes, there it goes. All right, so our proportions. A proportion is the relationship between two equal ratios. So proportions are usually expressed as two equal fractions. They give us an example of A over B is equal to C over D. It can also be expressed as ratios, A to B. When you have the double colons there, that is the same as saying is equal to. So we have A to B is equal to C to D. When two ratios in a proportion are equal, the cross products of the ratios will also be equal. So we must multiply the outer terms called the extremes and then the middle terms called the means. This relationship is shown in figure 4-1 of your text. And then the answers of each multiplication must be equal for the ratios to be equal. So here's figure 4-1, where they're showing that the extremes have to be multiplied together. That's the outer numbers. And then the means are multiplied together, the inner numbers. The way we're going to do it, the way I'm going to show you how to do it, you don't even really have to keep up with that part. So they give you an example here, just showing you the relationship of the cross products. So we had two ratios here. 20 to 25 is equal to 4 to 5. So we can multiply the extremes or the outer numbers. So we get 20 times 5, which is 100. And we can multiply the means or the inner numbers, which is 25 times 4. That also equals 100. So these ratios are equal, and this proportion is true. Fraction proportions, and this is how we're going to deal with them most often in pharmacy. So to write a ratio proportion as a fraction proportion, we're going to change the double colon to an equal sign, and then we're going to convert both ratios to fractions. So they give us the example there of 5 to 100 is equal to 50 to 1,000, and as fractions, it becomes 5 over 100 is equal to 50 over 1,000. So if we need to solve a proportion for X, when one quantity is missing from that proportion, we will place the X where the missing information belongs. So the example they're providing us here is 5 over 30 is equal to 10 over what? And then we would cross multiply. 5 times X becomes 5X. 30 times 10 becomes 300. So 5X equals 300. Now that X is currently being multiplied to the 5, and we need to isolate that in order to solve for X. So that means we're going to have to divide by 5. And what we do on one side of the equal sign, we must also do on the other side of the equal sign. So when we divide the 5X by 5, 5 divided by 5 equals 1. 1 times X equals X. So we have just gotten X, right? And on the other side of the equal sign, we need to also divide the 300 by 5. And 300 divided by 5, I'm so sorry, will equal 60. So X in this scenario equals 60. I'm not going to work the think, pair, share. But we do have a couple of examples here. So I'm going to jot these down real quick and then we will stop and work them. So we have example 1 that is 50 to 250 equal to 10 to x. And example 2, I have 20 to 40 equal to x to 15. All right. So let me pull the PowerPoint slide down so that we can see what I got going on here. My apologies. I'm trying to make sure everything fits into the frame of the screen. And as you can see, I'm having a little trouble. There we go. All right. So I personally really like to rewrite these as fractions. It's just the way I operate. If you can operate with them in that linear fashion, by all means, go right ahead. So I'm going to rewrite mine like so. Right, I've turned both of my ratio numbers into fractions, and I'm going to work it as a fraction. So 250 times 10 is going to equal 2,500, correct? And if I cross multiply the other direction, I get 50 times x. So just like in the example we were looking at just a moment ago, the 50 is being multiplied to the x. So in order to get that x by itself, I'm going to have to divide by 50. 50 divided by 50 is 1. That's just going to equal x, right? And what I did to one side of the equation, I must also do to the other side of the equation. So 2,500 divided by 50 equals 50. So there's the answer to example 1. Now let's look at our second example. Now I have 20 over 40 is equal to x over 15. And again, I can cross multiply. 20 times 15, 300. And if I cross multiply the other direction, I'm going to get 40x. And I know I'm running out of room, so I'm sorry. I'm going to tilt this down. We can focus more on example 2. All right, now we're going to divide by 40 to isolate this x. And 30 divided by 40, I'm sorry, 30. 300 divided by 40. Should be 7.5. I know I don't have the best handwriting. So I got 50 and 7.5. Let's see how we did. So 50 was the answer for example 1, and 7 1/2 is the answer for example 2. So I expressed it as a decimal rather than a fraction. It's the same thing, right? All right. So here's another knowledge check for us. Let's give you a moment to see how you do with it, and I'll catch up to you. Okay, so there's the example that was on our knowledge check, and we are going to be solving for x. So again, Miss Jennifer likes to switch these two fractions. So I'm going to put 1 over 5 equals x over 20. Then we can cross multiply. 1 times 20 is 20. And that equals 5 times x. So I'm going to have to divide by 5 to get that x by itself. And what I did on one side of the equal sign, I had to do the other side of the equal sign. And 20 divided by 5 equals 4. So let's see how we did. And we came up with the correct answer. So look at us go. All right. I'm going to conclude this video here. Well, as far as the PowerPoint goes, I'm going to conclude this here. We're going to work just a couple of more practice problems, and we'll do percentages in a separate video. Okay, so I have some example problems pulled up here for us to look at utilizing our ratio proportion method. This is out of chapter 6 in your pharmaceutical calculations for pharmacy technicians text. This is the last text listed under your readings tile in Moodle. And I am on textbook page 91 if you want to follow along in the text. So the first order we have here, we're going to look at letter A, if you will. So we have an ordered dosage for 24 milligrams. And it says the solution that I have, or the solution strength that I have actually available in stock is 12.5 milligrams, 12.5 milligrams in 1.5 milliliters. So they're asking me how many milliliters do I need to give this patient to achieve the 24 milligram dose? So I'm just going to make a few notes here. We have our script that is calling for 24 milligrams. OH for on hand. We have 12.5 milligrams in or for every 1.5 milliliters. So how are we going to determine how much to give this patient? Stop the share where you can see my math much better. All right. So I always like to start with what I actually have. And in this case, that's what I have on hand, right? So I'm going to set this up as an actual fraction, 12.5 milligram over 1.5 milliliters, because that's what it said I had in stock on hand. So that's what I'm starting with. I'm going to put this equal to, I'm going to put my milligrams on top because I have milligrams on top on this side. So when we work ratio proportions, your units have to match horizontally. So across from each other. So if I have milligrams here, it has to be milligrams here. If this were grams, this would have to be grams. If this were liters, this would have to be liters. And I'm looking for the number of milliliters it will take to achieve that dose. So I'm going to cross multiply. And so 1.5 times 24 equals 36. If I cross multiply in the other direction, I get 12.5x. So I already know I'm going to have to divide by 12.5 to isolate that x. And because I did a division on one side of the equal sign, I have to do that same division on the other side of the equal sign. So 36 divided by 12.5. Now it truly equals 2.88. However, if I were going to measure this up to give to a patient, I would most likely round that to the nearest tenth, which is actually what the assignment said for these examples that we're looking at, to round our answers to the nearest tenth. Remember, the tenth is one place past the decimal. All right, let's look at our next example. Okay, here's example B from the same pharmaceutical calculations textbook page. Just moving down to the next example. This time our order calls for 30 milligrams, but on hand we have 40 milligrams in 2.5 milliliters. So again, I'm going to start with what I actually have on hand, which is 40 milligrams for every 2.5 milliliters. And I'm going to set that equal to 30 milligrams. I know that the 30 milligrams has to go here on top because I have to match my units horizontally, right? And I had milligrams on top of this other side. So that means that what I'm looking for, or X, is going to be the milliliters, right? And then we can cross multiply 2.5, times 30 is 75. And when we cross multiply the other direction, we get 40x. So we're going to have to divide by 40 on both sides just to get this x all by itself. So 75 divided by 40. 1.875. Remember, we're rounding to the nearest tenths. My official answer would be 1.9 milliliters. All right, I'm going to work one more of these. All righty, so here's our next example. I apologize, my email is not showing up very good down here. There we go. That's what that's supposed to be, email. So this is example C from the same pharmaceutical calculations textbook page. We're just using this as another example for practice. So if on hand I have 0.6 milligrams in 0.8 milliliters, but my prescription calls for 0.3 milligrams, how many milliliters will I need to dispense for this order? So once again, starting with what I have in stock. Here's my 0.6 milligrams per 8 milliliters. Excuse my funky handwriting. And I am looking for we're looking for 0.3, not 0.03. We're looking for 0.3 milligrams. And so we need to find out how many milliliters that consists of. All right, so we're going to cross multiply 0.8 times 0.3. 0.24. And when we cross multiply the other direction, we're going to get 0.6x. So I've got to divide by 0.6 on both sides. That one already came right out to the 10th place. So that is 0.4 milliliters necessary to fill that order. I hope this video has helped you with solving for X with the ratio proportion method.